Let's do this. Here's the deal, okay? Your homework is 3 questions. That's oh so very manageable, okay? But listen to me. One of the questions in the homework you're not going to know how to do because of the way the question is worded. You don't need to do it the way the book is asking you to do it. Like it's going to say, refer back to example 1. You don't need to. We're doing all of this in the calculator. So you're going to plot the 3 points they give you as points in your calculator. Okay? What? About to die. Why? Oh, the battery life? Okay, here we go. So the only difference today with what we did the last time you did all the calculator stuff, the only difference, excuse me. The only difference is we are not doing a line of regression anymore, okay? We're not doing linear regressions. We're doing quadratic regressions. So your only difference is going to be one button on your calculator that looks like this, not this, right? We're not doing the line of regression anymore. We're doing the quadratic regression. That will be the only difference. The rest of it, your process will look very much the same.
So on everything,
okay?
you're using the calculator?
You're using the calculator on every single one of these. It's beautiful, right? Okay, here's the deal. Here's what we're doing. It says the table shows temperatures for a day in October in Sacramento, California. Graph the data on your calculator, label your X and Y scales. Here's a couple things I want you to note. Look at these times. What are they?
It's times during the day, Mr. Hogan. It's 24-hour clock, by the way.
It's 24-hour clock. It's military time, okay? Why would we use military time?
Because it's accurate.
Because
It's show respect to the troops.
Is that what you
It
don't
won't
need
go
AM?
backwards.
Yeah.
Right.
That's
So
why you don't need AM.
think about it this way, okay? If I were at 12 noon and I wanted to go 1 hour later and I went to 1,
You go all the way back to 1 o'clock.
mathematically that's going to drop way low on your graph, right? We don't want that. So we're going to use military time so that it follows a true pattern of how the time is changing. The other thing to note is you don't need to plug in the zeros, okay? You can just plug in 8, 10, 12, 14, 16, 18, okay? Okay, so go on your calculator. The first thing I want you to do is click Y equals. If you have an equation in there right now, clear it. Make sure your plot is highlighted, right? Plot 1 should be highlighted right now, or you're not going to get any points. Okay? Now go stat, edit, and you're going to put your points in. Okay? If you have an L1 set up right now, clear it. Do you remember how to clear your L1? Clear, enter, yes. So you're going to plug in your times in L1, 8, 10, 12, 14, 16, 18. Put those in. 8, 10, 12, 14, 16, 18. Okay, go to L2 and put in your temperatures, 52, 64, so on and so forth. Okay. All right. How do you remember what you pushed to graph these? Zoom 9. Okay, hit zoom 9.
It just says error.
It says error? Uh-oh. I put one of mine in wrong.
Wait, so instead of line right, you use one right?
Yes. It's done.
Yeah, but don't do it yet. Just okay. I don't know. Well, I'm just gonna plot this.
Is this the same thing we did?
Very similar. The only difference is quad reg instead of line reg. We'll get there. Okay, listen. You need to label your axes, label your scales. So your time is going to be on bottom. Your temp is going to be on the side. Do you remember how to tell your scale? What do you hit? What button? Hit window, and it will tell you your X min is 7, your X max is 19, your Y min, we're gonna just call that 47. We don't need weird decimals. And your Y max is 86. Do you see those numbers? That's, you just click window. Window.
How do you know where to put them?
Because this is your X axis and your Y axis, right, on a coordinate plane. So your Y min and Y max, my min would be your bottom, Y max would be your top. Okay? Okay, so do your graph again, and we're gonna plot these as accurately as we can. So you have a point here, here, here. Okay, should look something like that. Are we getting that? Okay. Here's what you're gonna do now. Part B, it says, what is the quadratic model for this data? What they're looking for is an equation that is in the quadratic format. So ax squared plus bx plus c is what we're looking for here. Here's what you're gonna do. Do this with me so that you know your steps. You're gonna go stat, click over to calculate. Now here's where we did line reg before. That's what's changing. The one right below that, number 5, is quad reg. Click that. Is that different on you guys's? Okay, but it is, yes. Instead of 4, you do 5. Okay, quad reg. Okay, so you should be seeing right now. Let's just do this. Oh, come on.
I don't see that on my card.
What is it worth? Maybe. Come on, guys.
Is this what you're seeing right now?
No, start.
Yes.
Yeah. That's what I see.
Okay. From here, we want to calculate
To the Y1.
the quad reg.
We don't have to plug it into Y1?
You don't need to store it because I don't need the line.
Wait, so we go down.
If you wanted to, you can. If you want to see the line, that's fine.
I do want to see the line. I do.
Okay, if you want to see the line, you're going to go calc, quad reg, go see store regression equation.
You don't have to.
You don't have to. Alpha, trace, y1, calculate. I'll show you. Then if you click graph right now, you'll see the line. Okay? Okay, but this is what you should be getting.
You never hit alpha.
Okay, so what you're doing with those numbers, your A is your A, your B is your B, your C is your C in that quadratic equation. So it looks like this. Y equals, we're going to do 3 decimal places. So negative 0.469 x squared plus 14 I'm going to run out of room. Sorry, guys. 716x minus, I'm going to go down here, 36.121. Okay? That is your model. That is your equation for the quadratic here. Okay? That's part B. C says use your model to predict the high temperature for the day. At what time does the high temperature occur? Okay, this is just like we've been doing. You're going to find the vertex, right? The maximum is your vertex. We're looking for the high temperature. We're looking for the max. So what you're going to do is find vertex here by doing x equals negative b over 2a. And these ones you're going to want to just plug into your calculator, the whole thing. So this is going to be a negative b, so negative 14.716 over 2, and your a is negative 0.469. Okay? Make sure if you're going to plug this into your calculator as one full thing, you have to put these parentheses in. If you don't put parentheses around those bottom 2 that you're multiplying, you will not get the right thing. Okay? So negative 14.716 divided by parentheses 2 times negative 0.469, end your parentheses, and you get this number. Okay, that's our x. What was our x representing? Time, right? Our x was our time. Okay, now here's the deal. This is military time. Does that make sense for military time? No. So what, I guess that's not the right way to say it. How we need to think of this is a length of time, not a time itself. This is not 1,500 hours and 68 minutes, okay? This is, what we're gonna do with this is we need to figure out no, I said that wrong. Reset. Ready?
No.
Okay. Here's what we're doing. This is 1,500 hours, but 0.689 does not make sense for military time, right? So what we're gonna do is we're gonna take that 0.689. Hours are in how many minutes? 60. So you need to take this 0.689 and you need to multiply it by 60, and that will tell you your minutes, okay? So 0.689 times 60 gives you 41.34, okay? We're just calling that 41 minutes. So here's what it is. You have a time, 1,500 hours is what time? 3, okay? So this is a time of 3:41. Does that make sense?
Where did you get the 3.6?
1,500 hours, right? We're turning our military time into normal time.
Oh, so you misproven.
I mean, I guess technically you could say 1541.
You misproven for 25.
Hold on. What were you asking? Times 60, because we're turning it into like minutes, right? Okay, so this is 3:41 p.m. Hold on. Okay, I want to know at what time does the high temperature occur? This is when your high temperature occurs, at 3:41 p.m. But it also says use your model to predict the high temperature. So we want to know what the high temperature is, right? The high temperature is at 3:41, yes. Here's what we have to figure out, okay? At 3:41, what is your temperature? Means we're taking this 15.689 because you don't want to try to plug 341 into your problem. 341 is the same as 15.689, right? So we're going to take that and we're going to plug it in for x. So it's going to be y equals negative, excuse me, don't be rude. Pay attention. This squared plus 14.716 times 15.689 minus 36.121. Here's the thing. It looks horrible. You're plugging it into your calculator. It doesn't matter.
Jared has this calculator.
So, yeah, do that in your head. So you're plugging this into your calculator. And when you plug that into your calculator, you should get 79.316. Okay? Here's what it means. At 3:41 p.m., you get the high temp of 79 degrees. Right? That, or what?
You just go to the weather channel and like just.
No, you're predicting. You are predicting, not the Weather Channel.
It's his job. He gets paid.
Mr. Reno,
Nobody expects.
You plugged something in wrong then.
I can guarantee that's not the high temperature because at 1,600 hours there was 80.
It's a prediction. It's a prediction. It's based on a curve, right? here's about what it will be. So it's not gonna, like, it's not that this is necessarily the truth. It's here's what we expect to happen. 79 is good. Yeah. What are you doing? Okay, this one's easier. This one's gonna look nicer. Are you ready? Second one. You guys know you are taking a quiz on this on Friday, right? So the fact that you're like writing it off is a bad idea. Come back, pay attention, do this with me. This is it. You have very short notes today. They're not long. Okay. Number 2. A study was done to compare the speed X in miles with the mileage Y in miles per gallon of an automobile. Okay? Your first job is to graph this data on your calculator. So you're going to click. If you stored your Y equals, get it out of there, first of all. You don't know how to do what? Get the Y equals out? So click Y1. Click clear if there's an equation in there, if you stored it. Okay, now go stat. Stat edit. Clear your L1 and your L2.
I second that.
It goes quick. This is, see, the whole purpose of this is so you don't have to, the whole dolphin, okay, is that you don't have to do so much by hand. So you have all these numbers, let the calculator do it for you. Okay, so stat edit.
Can I ask my question now?
Yeah, what?
On the homework, you want us to not do the L1 that is there and do the L1 you put in campus?
Just on the one question. Yeah. It's the same L1, it's just you have to think about it that way. Maybe if you just waited and didn't do the homework while I'm trying to teach the lesson, it would make sense. Because then I could answer your question.
She said.
That's so gross.
I'm sorry. I'm so sorry.
Did you get that on video?
Sure did. You're recording. All of your madness is on video. Okay, here we go. Get those numbers in.
I'm sorry, class.
Wow. I'm watching. I feel like I'm dirty now. Like I feel like I need to go take a shower.
Because of a burp?
Like, no, yeah.
Are you putting your numbers in, people?
It just takes a long time.
All right. Shh. Tell me what you do.
Then you enter the numbers.
So your numbers are in. What do you do next?
You hit zoom and then you hit 9 and you get this thing.
Zoom,
That looks like a weird
9, and you get
and
an M-ish. Okay, so plot those on your thing.
no.
Um, okay, so you have all your points. Then you want to make sure you label your sides. So this is speed, right? That's your X. This is your mileage. Okay. How do I see my window?
Miss Rubin.
You hit window. Okay, so your X min is 9. Your X max is 81. Your Y min, we're going to call that 21. And your Y max, we're going to call that 32. Okay? So that's part A. Part B, what is the quadratic model for this data? So you're trying to come up with your equation. What do?
You gotta go to stat.
Stat.
You gotta go to calc, and then you gotta go to quadratic.
Right, so slow down. Stat, calc, 5, right? Quad reg. Then from there, calculate it.
To the third decimal.
You get an A, a B, and a C, 3 decimal places. That's going to look like this. Y equals a negative 0.008 x squared plus 7.746. Shoot, I really need to write smaller.
Or just zoom in.
I know. 7.6x, 7.746x plus 13.469. Sorry for my smaller numbers. Okay, did we get that? A, B, and C? Okay, so part C, it says use your model to predict the speed at which the mileage is the greatest. It does not ask you what is the mileage at its greatest. It says predict the speed. So what are you finding?
The speed.
Just the speed, which is x. Okay, you only have to solve for x on this one. You don't need to find your y. The way you find your x is by doing what? Negative b over 2a. Okay, so you're going to do a negative 0.746 over 2 times a negative 0.008. Don't forget these parentheses if you're going to plug it all in at one time. Okay? What do you get from that?
An answer.
Yeah.
Excuse me.
It's so gross.
I can't help it.
Yes, you can.
What do you get?
I don't know, I've got an error.
You got an error?
I got 29.75.
This is what you should be getting.
46.625.
Did you plug this in?
Let's give it a try. So is that
Yes?
just the answer?
Did you use that?
Check your, did you put your double parentheses? Did you put these parentheses
Oh,
in?
I put 476, not 7.
There you go.
Stop. Hammer time.
That's a good lesson, by the way. What a drastic difference a different number is. What is he doing?
They're waving at us.
Who is that?
That's Bartholomew.
Go
and
away.
the-
Okay. What does this mean?
It means that 46.625 is the x for the
That's the
speed.
You were going 46 miles per hour.
There you go. Speed x in miles per hour. So this is about 46 miles per hour. Okay?
That's not very fast.
When your mileage would be the greatest. Questions on that?
1 second.